Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, working on unit number 5, lesson number 6. We're talking about those functions and talking about some independent and dependent variables. So what we're going to be doing in this lesson is we're going to be talking about which graph matches with different situations. So in the warm-up, it has 5 different pictures where a dog is running towards the picture. It says, here are 5 pictures of a dog taken at equal time intervals. It says Diego and Lynn drew different graphs to represent the situation. It says they both used time as an independent variable. What do you think each one used as the dependent variable? And be able to explain it. So again, what it's saying, as time went from left to right, so for each of these, we're going to say both have time as that independent variable. And just remember, when you're thinking of independent and dependent, you're thinking of the x-axis, and as you're thinking of the dependent variable, dependent, that just means it's going to be the y-axis or that vertical axis. All right, so for the first one, we can say Diego's graph, is going to be the distance from the edge of the grass. So he's saying, as the dog gets closer, or as time goes further on, the distance increases from the edge of the graph. So notice how the dog is getting further away from the edge of the graph. And then on the second one, we can say distance from the camera is going to be Lynn's graph because the dog is getting closer. So then we could say that both graphs are good depictions of the scenario because they're using different variables as dependent variables. So even though the graphs look different, depending on what you label as the independent and dependent variables, it will change your picture. All right, for the second part, it says, which graph is it? For each situation, name the independent and dependent variables and pick the graph that best fits the situation. Or sketch the graph if one isn't provided, label the axes, and answer the question, which quantity is a function of which? So be able to prepare yourself to answer those. So for the first one, it says Jada is training for a swimming race. The more she practices, the less time it takes for her to swim one lap. So we can say for this one, we're going to say, well, this is going to be this first graph. We can say the independent variable is going to be time practiced, and that's actually going to be the independent variable for each of these. So we're going to say time practice is going to be on the x-axis, and then we're going to say one lap time is going to be on the y-axis. So we're saying, that initial start, their time is going to be higher, then as they practice on, their time will get lower. In the second graph, we can say the pace is going to be the dependent variable, where the independent variable is going to be the time practiced. So again, x-axis is time practiced, y-axis is your dependent variable. And for on that last one, we're going to say this, we're going to say the x-axis or independent variable, time practice again, but your y-axis this time is going to be time taking off the total lap time. So notice how it starts lower, but as they practice more, there'll be more time off of that lap time because that will be faster. Then for the second part, it says Andre adds some money to a jar in his room each for 3 weeks, and takes some out in week 4. So if we actually put it like this, if we have our x-axis is going to be weeks and our y-axis is going to be the amount of money, we can say, can make a graph like this. So that we're going to say it's going to be a piecewise function. So it's going to be kind of like a couple steps like that, where it's increasing for the first 3 weeks, and on the 4th week, he's going to take some out, so it's going to decrease. And so then we can say this, we can say the graph shows the money in the jar increasing once per week 3 times, so 1, 2, 3, and followed by a decrease in week 4, which is that last step. It says the amount of money in the jar is a function of the number of weeks. So make sure you're saying and seeing how those are set up. Towards the bottom, on the front, now on the practice problems, it says match the graph to the following situations. And we can use that graph multiple times. So for each, match the name of a possible independent and dependent variable and how you label those axes. So again, make sure you remember we're saying x is going to be our independent and y is going to be our dependent. So for that first one, it says Tyler pours the same amount of milk from a bottle every morning. And so we could say the graph that goes with it is going to be that graph B, and that makes sense because he pours that same amount each time. However, we can say the independent variable, the x-axis, is going to be the number of days, where the dependent variable is going to be the amount remaining in that bottle. So notice how it's decreasing as the number of days goes on. For the second one, it says a plant grows the same amount every week. So we're going to say the function that goes along with that, or the graph that goes along with that, is going to be that graph A. We can say graph A, let me make sure that says equals, there we go. The independent variable is going to be the number of weeks, so that's going to be our x-axis, and as time goes on, the height of the plant is going to increase. So our dependent variable is going to be the height of the plant. And then for that third one, it says the day started very warm, but then it got cooler. So we're going to say that that's going to be that choice or graph C, where the independent variable is going to be the time, and then the dependent variable is going to be the temperature, because the temperature depends on the time of the day, because it gets colder as the day goes on. And then for that last one, it says a carnival has an entry fee of $5, and tickets for rides cost $1 each. So we can say that goes with that first one, because we're saying that independent variable is going to be the number of rides, where we start out at 0, we still have to get into the carnival, so we're going to say that's going to be 5, and as we increase, our dependent variable is going to be the amount of money spent. Already on the back, looks like this. It says, try to recall that formula for the area of a circle. Let's try to write it down. So it says, write an equation for the circle's radius, r, and area, a. So we can write the equation like this. I'm going to say a is going to be equal to pi times the radius squared. Then it says, is area a function of radius, or is radius a function of area? And we can actually say yes for both, because if we rewrote it where a is equal to pi times radius squared, that's 1 for both. Or we could say, we could have it like this. We'd say area, or sorry, we're going to say radius is going to be equal to the square root of area divided by pi. So that's another way to write it if we wanted to write it like that. And then for part C, it says fill in the missing parts of the table. So we're saying if we have a radius that's 3, our area is going to be 9 pi. If we have an area that's 16 pi, we can take the square root of 16, which that will be 4. If we have a radius that's 1/2, we're going to have to square both the numerator and the denominator. So we're going to say 1/4 times pi. And then for the last one, the square root of 100 is just 10. So notice how each of those values matches up with one another. And then on the last one, it says the points with the coordinates 4, 8, 2, 10, and 5, 7 all lie on that line. So let's graph the line first. Even though I have these things in here, let's plot these points. So I can go 4 to the right and 8 up to graph that point. And then I go 2 to the right, 10 up. And then I have 5 to the right and 7 up. And they should all fall on a straight line because it's a linear function. And be able to graph that line through those points. So something like this maybe. Perfect. Alright, so it says for part B, it says what is the slope of the line you graphed? We're going to say it's -1 since it goes 1 down for every 1 step right. And what does that look like? Well, we're saying, if we build that staircase, it goes down 1. Try that again. It goes down 1, for every one step to the right. So if you want to, you can build that staircase and see how that works. It's going down one step and to the right one step. Make sure you're writing your slope as a fraction, because we're saying, again, slope is still equal to the change in y divided by that change in x. And for that last part, part C, it says, what does this slope tell you about the relationship between the lengths and the widths of rectangles with perimeter of 24? And the reason why they're talking about that, because if you look at perimeter, we would say perimeter equals 2 times the length plus 2 times the width, which is very similar to our equation 2x plus 2y equals 24. So that's why they're saying perimeter 24 on that one. So it says a slope of -1 means that the rectangles of perimeter 24, or that for rectangles of perimeter 24, every extra unit put into the width is one less unit put into the length. So there's a correlation between those two. So you have to make sure that you're saying that one side is going to be longer than the other. Be sure to check with me if you have any questions. And as always, super slam that subscribe button.